In ionic addition reactions, we have an alkene, which can function as a nucleophile. We have a carbon-carbon double bond here, which is a pi bond. Remember what a pi bond is. It is first you have a sigma bond between the two carbon atoms, and then you have overlapping p orbitals. So the pi bond is a region in space of electron density and can serve as a nucleophile. And when the pi bond serves as a nucleophile and attacks some electrophile, E+, there are two ways that this can happen. If E+ does not have a lone pair, for example, let's say we're attacking a proton, H+. So the double bond attacks H+, and gives us the following carbocation, and the carbocation is then subject to attack by whatever nucleophile is present. Let's just say X-. X- can be chloride, bromide, iodide. It doesn't even have to be negatively charged. You can have water attack the carbocation. If water attacks the carbocation, then you end up with something that has a positive charge. Here's water that attacked, and this oxygen has a positive charge. And then you need to remove the proton. And you can use water to remove that proton. And get your product, OH. This is one type of ionic addition reaction. Another type of reaction occurs when you have E+ that has a lone pair. For example, if you have molecular bromine, Br2. Now, the bromine-bromine bond is a covalent bond. However, when this molecule gets near the pi bond, the bromine-bromine bond is polarized. The electron density here of this pi bond polarizes this bond and gives you delta plus and delta minus. And now we have a nucleophile here and an electrophile here. And the nucleophile can attack the electrophile, the lone pair coming back down, this kicking off 3 curved arrows, and what we get is a bridged, positively charged intermediate, which we call a bromonium ion. And the bromonium ion can then be opened. Suppose we attack with bromide, and we kick this open. And we get the following compound. Now, these reactions are all ionic addition reactions, or all mechanisms that are ionic, but notice the difference. Up here, we have the pi bond attacking H+, forming a carbocation, and then the nucleophile attacking that carbocation. So there's 2 discrete steps, protonation followed by nucleophilic attack. Here, there are also 2 discrete steps. But notice that when the nucleophile here attacks this electrophile, because there's a lone pair on this bromine, we can form a bridged species which is then opened up via nucleophilic attack. These are 2 very different mechanisms for addition reactions, both of which are ionic addition reactions. And in your textbook, you're going to see both of these mechanisms, and they're going to be compared and contrasted. And you should take special notice of these 2 mechanisms, because you'll find that many of the reactions you learn follow this mechanism here, via formation of an intermediate carbocation, whereas other addition reactions will follow this type of scheme, where you form a bridged intermediate. And there are ramifications There are stereochemical ramifications, regiochemical ramifications. When you form an intermediate carbocation, you lose stereospecificity because the attacking nucleophile can attack from either face of the carbocation. But when you form a bridged bromonium ion, the reaction will be stereospecific. And you can look in your textbook to look at the stereochemistry of this reaction, and you should compare it to the stereochemistry of these types of reactions.